All right, let's get right into it. We're going to go way beyond the usual hype today and explore a totally different kind of AI. We're talking about one that doesn't just spot patterns, but can actually reason. This is the quest to build an AI that genuinely thinks. I mean, think about it for a second. A modern neural network can find a cat in a sea of photos with, staggering accuracy. But if you ask it why that's a cat, to actually explain its reasoning, like it has whiskers or it has pointy ears, it just can't. It's basically a black box that's brilliant at matching statistical patterns, but it doesn't really comprehend concepts. So the big question is, how do we close that gap between just recognizing things and truly understanding them? Well, to understand where we're going, we've got to look back. For decades, AI research has really evolved down two completely separate roads, creating what you could almost call two different kinds of AI brains. One is all about intuition and learning from data, and the other is all about logic and following a strict set of rules. So on one side, you've got the neural approach. That's the intuitive brain. This is your modern deep learning, the stuff that's amazing at perception, because it learns from just insane amounts of data. And then on the other side, you have symbolic AI, the reasoning brain. This is that classic, logic-based, old-school AI, built on structured knowledge and formal, explicit rules. Think of it as raw intuition versus verifiable logic. Here's the problem, though. For the longest time, these two brains didn't talk to each other at all. And it turns out, on their own, both of them have some pretty fundamental and, frankly, mission-critical limitations. This quote just nails the problem with even our biggest, most powerful neural networks. They are that student. Their ability to generalize is purely statistical, which is exactly why we get things like hallucinations and why they're so brittle when they see something new. It's the classic black box issue. We get an answer, but we have no way to audit the process because the reasoning is buried in a sea of vectors. The symbolic, logic-driven brain, it has the complete opposite problem. It's like a botanist who only knows one rule. If it has leaves and a stem, it's a plant. You show it a cactus and the whole system just breaks. This is what we call brittleness. It's incredibly powerful when things fit the predefined rules, but the second reality gets a little messy or unexpected, it just fails. And the neural intuitive brain, oh yeah, it has its own classic failure mode. You can show it a million pictures of real plants, and then you show it a super realistic looking plastic one. It'll say with 100% confidence, that's a plant. Why? Because all it's learned is the statistical pattern of what a plant looks like, not the underlying concept of what a plant is. It's pure intuition, totally ungrounded in logic. So you see the dilemma, right? We've had this powerful intuition that we can't really trust, and this rigid logic that can't handle the real world. So what if we could combine them? What if we could build a bridge between AI's two brains? Well, that's exactly what's happening right now. And this is NeuroSymbolic AI. At its core, it's a hybrid architecture designed to give you the best of both worlds. The neuro part, obviously, comes from neural networks. That's your intuitive, learning, perception engine. And the symbolic part comes from logic. That's your structured, reasoning engine. This is the key to building an AI that can not only perceive the world, but actually reason about it. So how does this actually work in the wild? Let's take a self-driving car. First, the neural perception part sees raw pixels and identifies shapes and colors. It sees a red octagon. This process is called neural-to-symbol grounding. Then that symbol, red octagon, is fed to the symbolic reasoning core, which has a hard, unbreakable rule. A red octagon is a stop sign, period. So, and this is the crucial part, even if the sign has stickers on it or the lighting is bad, the system understands the concept of a stop sign, not just a pattern of pixels it's seen before. And this table just lays it all out perfectly. Let's walk through it. Symbolic AI is super explainable, but brittle. Neural AI is amazing with data, but it's a total black box. But now, look at that neurosymbolic column. It pulls in the strengths from both sides. It learns from data, it can handle new situations using reasoning, and most importantly, its decisions are fully explainable. It really is the best of both worlds. But this combination, this synthesis, it unlocks something even more powerful. We can now move from an AI that just memorizes patterns to an AI that can actually learn how to reason about the world and update its own knowledge. The technical term for this is meta-learning, and honestly, it is a complete game changer. It means the system can update its own internal rules, its own logic, from just a handful of examples. So if it learns a new exception to a rule, you don't have to retrain the whole thing on a massive data set. It can perform what's called rule induction on the fly. It is literally learning how to learn. Okay, let's see how this plays out. Imagine you teach a standard AI model a pretty simple rule. Mammals have fur. Easy enough. Then you show it a picture of a whale. A typical neural network just glitches. It sees no fur, so its memorized pattern completely fails. It's totally stuck. But a neurosymbolic system, it doesn't just give up. It can actually reason its way out of the problem. It looks at other properties it knows from its knowledge base. Okay, whales give birth to live young, they breathe air, and it uses reasoning to figure out, they're still mammals. Then it actually updates its internal logic to refine its own concept of mammal. It just learned a more nuanced, more accurate rule about the world, all by itself. Now, this ability to reason and explain itself has enormous real-world consequences, especially for high-stakes industries where, trust me, it just works, is never, ever going to fly. This is what gives us AI that you can finally govern and audit. Because the AI can literally show its work, we can finally build in structural safety. We can actually write compliance policies as verifiable guardrails in formal logic. We can use runtime monitors to check an AI's actions before they're executed. And the big one, we can demand action provenance, tracing every single decision back to the specific piece of evidence and the exact rule it used. This creates a clear, undeniable audit trail, which is a massive game changer for any regulated field. And that's exactly why this tech is transforming fields where mistakes have huge consequences. In drug discovery, it's reasoning over complex molecular structures to predict interactions. In finance, it can flag fraud not just by spotting a weird pattern, but by checking a transaction against a formal knowledge base of compliance rules. In these worlds, explainability isn't just a nice-to-have feature. It's an absolute requirement. So we're really at this pivotal moment. We are moving away from these opaque systems that we just have to hope are right, and toward transparent, auditable partners that can actually explain their reasoning. The core challenge is shifting from just making AI more powerful to making it verifiably trustworthy. The question is no longer just about whether it's smart, it's about whether we can prove it. Stay curious.